Okay, so today we're going to talk about the structure of water because it's a bent structure, and it's actually easier than the methane and the ammonia that we've done previously because it's really not a 3D structure. And so therefore your Lewis structure and your structure of water, the actual molecule structure are going to be the same thing. But let's first off look at water. It's H2O. And so you've got two hydrogen. Each hydrogen has one valence, so that's two valence there. You've got one oxygen, that's 6 valence, and that's 2 and 6 is 8. And so I just make my oxygen, I attach my hydrogens, boom, boom. And so that's the skeleton of the Lewis structure there. But the oxygen isn't happy, and I haven't used all of my electrons. I've only used 2, 4 for that bond. And then 1, 2, 3, 4. Okay. Now I put in these as unshared pairs. 2, 4, 6, 8. Oxygen's happy. Hydrogen's happy because it's teeny tiny and it only needs 2. Okay. If you can hear that on the video, that's not thunder. That's me blowing your mind with chemistry. Okay. So now, whereas on the other structures we would need to redraw it because we have something that's protruding. Because there's only two things, this is a flat structure. You could build this and it actually lays flat on the table. There's nothing sticking up or back. So this is the Lewis structure and the molecular structure. Okay? So this is actually sort of the general shape of this. Now the other thing we need to remember with water is that it's made up of very polar molecules. Now, don't shoot me here. I'm doing this from memory, but I believe that oxygen has a 3.5 electronegativity and hydrogen has a 2.1. You take them away, you get a 1.4. And I know that if that isn't the right answer, it's pretty darn close. And what that indicates is that this is a very polar molecule, okay? And the reason that we look at this as a polar molecule is you got two hydrogens and two unshared pairs, so you've got like a top and a bottom. It's not the same on each end, okay? So like something like a methane where you have the same thing at every bonding point, that's going to be nonpolar because same, 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 same. We don't have that at oxygen. And in addition, because oxygen is so electronegative and hydrogen is so tiny, you get a very strongly polar bond, which leads to the intermolecular force, hydrogen bonding. So, hydrogen bonding occurs when hydrogen is attached to nitrogen, oxygen, or fluorine, okay? And so when you attach hydrogen to either one of these in a covalent bond, you're going to get this extra highly attractive intermolecular force known as hydrogen bonding, okay? Now, just to review though, the bond is made, and it's a polar molecule, and it's so polar that we get this hydrogen bonding. So we just remember that the oxygen is negative and the hydrogen, so there's this region of negativity around the oxygen because all the electron density is up around the oxygen. And there's a dearth of electron density. Dearth means less. A need of electron density down here at the hydrogen. The electrons just aren't down there much. And so it is positive.